Hi students, in this video I'm going to go over the notes of simplifying radical expressions. I just want to go over some vocabulary first. So this radical sign, this sign usually known as square root, this is a radical sign. And then it's square roots, cube roots, foot roots, whatever root we're looking for will be notated here in this spot right next to the radical sign, and it's going to be a super tiny number. Radicand is the word for what we have inside the radical sign. And if there is no index number, if there's no number there, it's usually assumed to be a 2. So up to this point, you have seen square roots because you ask yourself what number times itself 2 times is in here in the radicand. But that number could change to any other number. And then that means you're looking for different amount of numbers times itself. So here's next is the list of the perfect squares. These numbers that I boxed out are the numbers you get from multiplying numbers times itself 2 times. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. So this is the list of the first 12 perfect squares. The next examples I have below is an example of the process we're going to be doing. But these are all 4 examples of perfect squares, which means the answers do come out as whole numbers because they are perfect squares. When we work with non-perfect squares, we're going to end up with decimals. So that's why you have to have the skill of simplifying radicals. So just to show you the process, you're going to look at the number that you have inside the radicand and ask yourself, is there a number times itself that gives me 16? In this case, yes, 4 times 4 gives you 16. So if you rewrite the square root of 16 to the square root of 4 times 4, they are the same thing. And then let me just show you that. Square root of 16, square root of 4 times 4, they're the same answer. What you need to understand is why is the answer 4? The answer is 4 because you're saying that you have a pair of numbers times itself inside the radical. 4 times 4 is 16. So 4 is the pair of numbers that are times itself 2 times. So you take it out of the radical and you end up with the answer of 4 outside of the radical. That's what's scribbled right here. We scribbled down the radical because there's no other numbers left inside. So all these perfect squares, they don't have another number left inside after you take out the pairs. Look at number 2. 121 is the answer to multiplying 11 times 11. 11 and 11 are a pair, so they come out of the radical, and you just have 2 times 11, and that would be 22. Here's another example. 289 is not in this list above because it keeps going. This list keeps going, and you end up realizing 289 is the square root of 17. You can always type it in here as well, and you can have square root of 289 equals 17. That means 17 times 17 is 289. So we can take out the 17s out of the radical, and you end up with 6 times 17, since technically 289 square root of 289 is 17. And 6 times 17 is 102. So you gotta look at the coefficients that are in the front, bring them along with you through the process, and then at the end you multiply if you can. Last problem here is 3 square root of 400. If you type square root of 400 in the calculator, it does give you a whole number of 20. So you could have jumped straight from 3 to all this process to just saying 3 times 20 is 60. But just to show you how it's 60, we find the factors of 400. All of these factors are the factors of 400. I showed you in the calculator that we could do it the old way, which is prime factorization, break down the number to numbers that multiply to get 400. But we realized through practice that it was time consuming. So use a calculator if you have one to find the factors. Number. So again, you press menu and then number and then factor. And then you type the number you're trying to factor, and it gives you the prime factors that give you 400. So 22 is 2 to the 4th power, and then 5 times 5 is 5 squared. That just means that if I multiply these numbers times itself, it'll give me back to 400. Now, once you have it in the primes, you want to factor out pairs. Take out a pair, that's a 2. Take out another pair, that's a 2. Take out the 5, that's a 5. So these groups become only one number on the outside of the radical. And then you get 60 if you multiply them back together. I'm going to go over in detail to the non-perfect squares so you can understand how we end up with the radical expressions instead of just decimals. A lot of you are used to just writing square root of 32 in the calculator, getting a decimal version and saying that's my answer. And that's good. The calculator can do the answer for you. But what if the answer is not decimal? You want to again learn how to either break this down by hand into its factors or use the calculator to help you find the factors. So like 32 could be broken down into 4 times 8. And then 4 could be broken down into 2 times 2. 2 and 2 are both primes. So I'm going to circle them just to say I'm done breaking those numbers down. 8 is 4 times 2. So again, 2 is a prime. And then 4 is 2 times 2. So all of these circle numbers are the prime numbers for 32. I'm doing the 2 times itself 5 times. And again, the shortcut for that is using the calculator. You press menu, number, factor, and then you type the number you're trying to factor, and you get to the 5th power, which means 2 times itself 5 times. From here, you're going to circle or just see the pairs that are going to come out. So that's a pair. That's another pair that's going to come out. And then this 2 that's left inside, we can't take it out because it's not a pair. So you leave it inside the radical. Then you multiply 2 times 2, which is 4. And then you put the square root of 2 next to it. And that's your answer. That's the simplified radical expression for square root of 32. If you're not sure that you did it correctly, you can always type the radical expression they give you and then the radical expression you found as an answer. And notice that the answers are the same next to each other. All right, I'm going to go over the odd numbers so you can try the even numbers on your own. And also so the video could be a little bit short. All right, number 7. I'm going to use the calculator and just press menu, number, factor, and I'm going to type 147 so I could find the factors of that. So according to the calculator, it's 3 and then 7 squared. So that's 3 times 7 times 7. And then this shows you that you have a pair right there that needs to come out. So that's 7 on the outside. On the inside, we still have that 3. And if you notice there's nothing else we can do, there's no numbers to multiply or nothing, so this is your answer. And just to verify that that's correct, you could type square root of 147 and then 7 square root of 3, and they are the same decimal. Okay, here's another example, square root of 48. If I type menu, number, factor, and type 48, the factors of 48 are 2 to the 4th power times 3. So 2 to the 4th power times 3. And the pairs here are this one. So you write them one time on the outside of the radical when you take them out. So one group of 2, one group of 2, and then there's a 3 on the inside. And then this one, 2 times 2, you multiply it back together, so that's 4 square root of 3 as your final answer. To double check, you type square root of 48 and then 4 square root of 3, and they should be the same decimal. So that's the process of simplifying radical expressions. Try number 6, 8, and 10 on your own and pause the video and then check if you got the right answers. Okay, so for number 6, the answer you should have gotten was 6 square root of 5. For number 8, the answer you should have gotten was 5 square root of 7. And then the answer you should have gotten for number 10 was 6 square root of 6. If you didn't get these answers and you want to know how to get those answers, just come and see me in class. I'm going to go over a couple more, number 11 and 13. So here, a negative is in front as the coefficient, so just see it as -5 times whatever square root of 150 is. So if we find the factors of that, we're going to press menu number factors. Oh, sorry. And then you put 150. So that's 2 times 3 times 5 times 5. And then the pairs here is just the 5s. So that's going to come out. The 2 and the 3 stay on the inside. And then there's a -5 in the front that needs to be multiplied times that 5. So that -5 times 5 multiply each other and they become -25. And then these 2 and 3 multiply each other and then they become 6. So that's the answer for that one. Okay, for the next one, we have -3 times square root of 28. If I do the factors, we do menu number factor, 28. Then I get 2, 2, 7. And then in this case, the 2's are the pair. Those come out. And then you have the -3 in the front. You have the 7 that stay behind. And the -3 times 2 is -6 square root of 7. And as usual, if you want to check your work, you can always type this -5 square root of 150. Gives me this decimal for that one. And then the answer we got is -25 square root of 6. And we get the same answer. For the next one, we're going to have -3 square root of 28 for this one. And then the answer we got was -6 square root of 7. And then it's that. So pause the video and try number 12 and 14 just to see if you get it. If you don't have a calculator at home to do the factors for you, you could factor them on your own, but it's going to just be time consuming. Number 12. If you're ready to check if you got it right, number 12 will be 64 square root of 2. And then the number 14 will be 32 square root of 6. So if you didn't get those answers, come and see me in class during tutoring or sometime during the day so I can help you understand these better. I hope this video helped you.